Hello, today we will solve LeetCode problem 260. In this problem, we have given an integer array nums in which exactly two elements appears only once and all the other elements appear exactly twice. So we have to find the two elements that appears only once, and then we have to return the answer in any order. Okay, and then here we have to write an algorithm that runs in linear runtime complexity and use only constant extra space. Okay, so these are the constraint, and this is the first example. So here you can see that 3 and 5, the frequency of these numbers is 1. So we can print it here. So the first solution is, if we didn't pay much attention to this information, then we can use a hash map. And in that we can store a frequency of all the variables, all the elements. After that we will run through this hash map, and if there is frequency of any number is equal to 1, then we will print it. So this is the first solution. But in that solution the space complexity is of n, or you can see of n by 2. So that is not the solution that we have to implement in this problem. So we'll try something else. Okay. So if we see here in this problem 1 2 1 3 2 2. Okay, so here we have 1 2 times 2 2 times. So each element will be present twice and only two elements will be present once. So if we observe this whole array, in that scenario, for 1 1 we will get 0, for 2 2 we will get 0, and we will only get 3 and 5 here. The XOR value of 3 and 5. Okay, so this will be the final XOR of this whole array, because for all the other elements it will be 0, and if we do XOR with 0 we will get the same element as an output. Okay, so this is the first step. After that, now we have to extract these two numbers from the available XOR number. So what we can do, let's assume you got something here as an XOR value, and the binary representation of that number will be something like that. Let's say. Okay, so this is the binary representation of the XOR value of our array. So if we see here, let's assume if I get this element 1, then I'm sure that in these two variables a and b, 1 will be 0 at this bit and 1 will be 1 as at this bit. That's why 0 and 1 will be 1. So like that we can find out the original number. Okay, original number. So what does that mean? So what we will do, we will put, let's assume if we get on this third position 1, in that scenario we will put that number into B. Otherwise we will put that number into A. So what does that mean? So let's assume in 3rd polynomial we have 3 elements. So 2 elements will be same. So we'll get 0 0 for the XOR value for that element. And for the last one, we get the original number. Okay, so that's like that we are splitting the numbers into two numbers, because this is the final answer and A and B. These are the values that we want to get. So now I will write the algorithm so that we can understand it in a better way. So first of all, our initial XOR value will be 0 and we will run in num. Okay, so this is the final XOR value of our list. After that, we calculate the last bit from the right-hand side. That value is 1. So for that, there is a simple way. Like we can also use a for loop. Like let's assume we convert it into a binary representation, then we run a for loop and then we'll get the position of 1. Or we can do one more thing here. We can directly get the bit is equal to if we do XOR with minus XOR and minus XOR. So like that also we can get the rightmost set bit. Now these are our numbers, num1 and num2 is equal to 0, 0. Now again we'll run through our list num in nums, and here we will compare if num and our bit. So let's assume num and bit, they both are, let's assume in the number we get 1 at that particular index. So in that scenario we'll took that num in number 1. We'll treat as a number 1, okay. So here we'll get num. In the else condition we will assign it to number 2. Okay, so we are splitting all the numbers in our list using that particular bit. If it is 1, we will assigning it to number 1. If it is 2, it is 0, we are assigning it to number 2. So like that, we are filtering all the data. And in the end, we can simply return num1 and num2 because the places doesn't matter here. Like the 3, 5 and 5, 3 both are this correct answer. Okay, so now I will run it. Okay, so the test cases are passing. We are not getting any error here. Okay, now I will submit it. Okay, so the answer is correct. Space complexity is also good. And now let me explain the solution once again. So first of all, we are getting the XOR of our total array. After that, we are getting the rightmost bit, that value is 1. Then we are filtering out all the numbers in our array using that bit. If it is 1, that will go in number 1. If it is 2, that will go in number 2. And in the R, we are returning our values of number 1 and number 2. So this is the whole logic behind it. And like that, we can solve this problem. Thank you for watching this video.